How's it going, everyone? Welcome, Elder Gonzalez. Today, let's take a look now at the chapter 5, when we need to speak and understand about the global scope. And after we now explore in this chapter about the scope and furthermore the closure, the idea is that by understanding this question, because it all started with a question, it's like how now JavaScript determined uh, at that particular statement which variable it can have access. And the other is that how JavaScript now solve is variables name or how solve is variables with the same name, right? So the TLDR of all of this is via the scope. And because now scope defined is a set of rules that analyze now the relationship between the variables, the function, and the block, all right, and also the global scope. This component and how they relate each other when you now as an JavaScript developer, as an author of the code, you put them in your programs, and the way how you put them in your programs influence now how this relationship is created, and therefore the scope structure, because this scope structure now happen is at compile time before the code is executed, which is similar of how, for example, compiler language, when they have now the classical compiler theory, is that it has three phases. So the first is the tokenization. So it converts all the source of a string. It converts the source text, this this text that is part of the language, whether it is C, Java, or any other compile language, Go, Rust, and then it takes all of those tokens and transform them into a meaningful tokens to the language, or lexing. And the difference is more like academic. So lexing is if the tokenizer now is going to decide if this particular token belongs to another token, or it's part of a different token. And then once it creates these streams of meaningful tokens for the language, then it's going to now convert into an abstract syntax tree, which is a data structure that allows the program, in this case the computer and us as humans, to understand with the structure of this, all right. And this structure is pretty much like any time that you wants to know the structure of something, all right, the structure of a building, the structure of your shoes, the structure of your fridge, of your cell phone. You want to know the structure, so we can know how the things looks like, and then now the code is generated, phase 3, final phase, right? And this is now, well, output all of those abstracts in the tree into now machine readable code. So this process that happens in compile language, the observable behaviors that in JavaScript is that when it comes to detect errors, and syntax errors, early errors, and hosting, all of this happens is before the code is executed. So we look at a particular example of how to do that, all right? But it turns out that because this is something that happens before the code is executed, now JavaScript behave like a compiler language, not in how the code is distributed, but how it is analyzed. So, because now the hosting or the relationship of how all of these variable functions and blocks relate each other when we as author define them uh, happens is before the code is executed. All right, we also look at what happened with the assignment to these variables, for example, which is part of the source and target. But it turns out that this assignment that we need to understand, at least to know what's going on behind the scenes, to have a mental model that, again, these mental models, the closer they are to the reality, the better. This is, for example, for mechanical stuff. uh, Understanding how these things work or having a mental model to initially approach to things might be useful. It's not the reality, it's not true, it's not work, it doesn't work the way it might be does, but at least act as a as something that uh, you can approach to, you can get started with. You can put your foot on the door. So, since we have is this, all right, and by this I mean is how do you put it? Did I lose my mind? Yeah. These assignments here, which the entire reason of talking about this is how these assignments happen, especially when you assign to a variable. And identify is, again, from the theory and for the practice, uh, what is the target of an assignment and what is the source of this assignment, right? So this is quite useful as we look at the variables and how these variables now are uh, belongs to which scope belongs to. So the TLDR of this is that when we understand that this scope is defined, so this scope defined is this relationship between the variables among different scopes, whether it's functions, block, and also the global here, which is what we're gonna look in today's video, is also the uh, that this assignment to a particular scope and the identification, the association with this identifier, aka the variable, to a particular scope, and then the assignment of these variables to a variables, it happened is at two different phases, and all of that assignments and association of these bindings happen is with the scope manager in the middle. So this conversation, which is part of how now the scope is determined, first by the compiler and then by the engine by assigning a value, all of this is handled by the scope manager. So this is part of the illustrating the lexical scope by first understanding that is, so Hal Simpson actually make a particular example here. So for example, let's going to assume that variables are marvels and functions and scopes are now buckets, and bubbles are what is the scope of these variables that can have access to. All right, but it turns out that the variables, and the assignment of the name to which scope it belongs, it happens at compile time, which is a conversation that has the scope manager and the compiler. And then when the code is executed, now the conversation is between the scope manager and the engine that is going to assign those values. So don't take my word for granted. You can take a look at the spec that is going to describe that. It says on the environment record, hey, the association of the identifier, aka the names of the variables and functions, and it is nested scope structure, okay? Uh, all of this are usually when you define is syntax like functions, like functions, block, and also try catch and the catch. But in our case, we're gonna focus on functions and block. And this now is an environment record that happen is when the code is evaluated. So I do think that this is quite revealing in terms of how now the language works. And since we're talking about now scopes, we also look at the different place where a scope can happen. So we look at the scope at functions, the scope at arrow functions, also is the scope at the block, and something known as shadowing, which is how now JavaScript handle is how now JavaScript handles when variables with the same name at different scopes are resolved. Okay, so this shadowing is a way to cache that, or to, in other words, is to variables with the same name at different function scope. They're going to. This is when shadowing happens, and how can use shadowing and so on and so forth, right? Okay, so um, so we're looking at the shadowing, and what happened with shadowing also is the function scope, and the arrow, and not only the function scope with function declaration but also function expression. And now the important thing is that the name that it is associated, right? And how with function expressions you can now have access to this identifiers, unlike arrow functions, which are lexically anonymous. So there is no way to reference into that unless you assign now to a variable as an arrow function expression. Okay, we also look at other places where we can define scope, and that to me was mind-blowing. So for example, parameter scope, this is also that happened. And the TLDR is that not necessarily to avoid that, but understand why we avoid that, because it can make our code very hard to reason about it. Not only that, on the parameters, it create now a scope, uh, but also is you can do now shadowing in that. So the TLDR is that avoid shadowing parameters in your scope. What avoid shadowing is uh, parameters, variables inside of your function. That's one. And the other is on the arrow functions. So because we are getting used to use arrow functions because it's quite convenient, but also it has some couple trade-off, because as I mentioned, arrow functions are not lexically so they are lexically anonymous. Arrow functions, they now have the same behavior as function in terms of its scope, and because as we describe, for example, is how a data is going to be transformed into another data, pretty much like an assembly line, all right, that you pass all of this material and it's going to pass through all of this particular step until you get a final output. All right, you get all of this material and the design, and you get a Tesla, right? You can say that pretty easy. Yeah, you can say that pretty straightforward, but it turns out that it's not that, as you might guess. So okay, now, and that also is that functions names are as a descriptor, and I do find that this is quite powerful here. Again, this is something that is way much more opinionated, but when you're defining is these functions treatment or pipeline, it is very powerful to describe what these functions that we're passing as callback to each one of those map or filter it is way much more descriptive. Okay, so yeah, I'll take that. I'll definitely take that. Now, finally, here we are on the global scope. Okay, on chapter 5, and here we are. No, chapter 4, my bad. Around the global scope. Chapter 3 mentioned the global scope several times, but you might still be wondering why a program outermost scope is all that important in modern JavaScript. The vast majority of work is now done inside of functions and mode rather than globally right now. But again, most of our code bases that you're gonna work, they are legacy. So it is important to understand global scope because some code bases must have at least implemented ES5 or EX6 features. But again, because the companies, they're depending on the kind of company that you're working, if they haven't implemented that feature, you're going to find that, and it's important for you to update this feature as you go. And also, it'll be quite rewarding, not only in terms of not only monetary reward, but also intellectually rewarding. So in any case, so as we look at this, right, it is good enough to just assert avoid using the global scope and be done with it. Similar, when I mentioned the parameter scope, I describe that not to avoid that, just to understand why we don't need why this is a food gun, why this might be a food gun. So the global scope of a JavaScript program is a rich topic with much more utility and nuance that you will widely assumed. This chapter first explores how the global scope is still useful and relevant to writing JavaScript programs today. Then look at different where and how to access the global scope in different JavaScript environments. So fully understanding global scope is critical. Fully understanding of the global scope is critical in your mastery of using lexical scope to structure your programs. So why global scope? It is likely no surprise to reader that most applications are composed of multiple, sometimes many individual JavaScript files. So how exactly do all those separate files get stickered together into a single runtime context by a JavaScript engine? With respect to browser executed applications, there are three mains. This is the question. How exactly all of these separate files get stick together into one single runtime in a single runtime context by the JavaScript engine? Exactly. How all of these stick together into one single runtime context by the JavaScript engine. And according to Kyle Simpson, there are three main ways. First, if you're directly using EX6 models, not transpiling them into some other model bundle format, these files are loaded individually by the JavaScript environment. So each model then imports reference to whichever other model it needs to access. The separate model files cooperate with each other exclusively throughout these shared imports. The separate model files cooperate with each other exclusively through this shared import without needing any shared outer scope. But again, if you are directly using EX6 models with the type model, okay, these files are loaded individually by the JavaScript environment. Each model, the important reference to whichever other models it needs to access. The separate model files cooperate with each other exclusively through shared imports without needing any shared outer scope. Secondly, if you're using a bundler in your build process, all the files are typically concatenated together before delivering to the browser and JavaScript engines, which then only process one big file. Even with all of the pieces on the application co-located in a single file, some mechanism is necessary for each piece to register a names to be referred by other pieces, as well as some facility for that access to occur. In some build setups, the entire content of a file are wrapped in a single enclosing scope, such as a wrapper function, universal model. See Appendix A. Okay, in some build step, the entire content of a files are wrapped into one single enclosing scope, such as a wrapper function. Okay. Universal model UMT, see Appendix A, etc. Each piece can register itself for each piece can register itself for access from another piece by way of local variables in that shared scope. So you have now this content of a file that is wrapped into a function. You have this huge gigant file, all right, that is being concatenated, okay, where some build steps wrap these files in a single enclosing scope. So hey, this is a one big file. So this is a one big file that is now wrapped into a function scope known as universal model, and each piece can register itself for access from other pieces by the way of local variables. So you define all of these different files here as a function wrapper and associate to the global scope in a variable. Mm-hmm. Look at this. Exactly. You see? Exactly. 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 And then you can call that inside of this. Exactly. So you define now a huge big file, the outer scope, that inside of this you define now some nested scope functions wrapper, all right? That those functions wrappers are now associated to an identifier, aka a variable. Mm-hmm. Like this. And if you want to call them, you can access to it. As shown, the Model 1 and Model 2 local variables inside the wrapping outer scope function scope are declared so that these models can access each other for their cooperation. While the scope of the wrapping outer function is not a function and not the fully environment global scope, it does act as a sort of application wide scope, a bucket where all of the top level identifiers can be stored. Exactly, a bucket that all of these top level identifiers can be stored through not in the real global scope. It is kind of like a stand-in for the global scope in that respect. And finally, the third way, because when this code is executed here, okay, when this code is executed, and this is a good question. This is a good question. This is a good question. This is a good question.
Recording in
In London,
progress.
we are 1,500 people in the studio all over the world. We have That's the size of the people currently working with us, meaning all of you. We have 47 active clients, and what does it mean? It means that we are a very specific business unit, which is we have a lot of big clients, and we don't have like a big long tail of hundreds, a hundred of clients. So we are really focused on the clients we have. But in terms of portfolio, that's not the story. One thing I would like to mention here, and then we'll go deeply there, is that 100% you see there. What does it mean? That in this year, in 2025, we, the AI Studio of Airlines, at the studio level, putting all the accounts together, we just hit our target. The company put a target on us last year, and what we were expecting to deliver this year, and we are aiming to close this year on 100% target. And of course, we are in 3 countries. Move forward. This is something before we start talking about the studio vision, I would like to bring to your attention. We have this is the leadership team. So this is people you maybe know. Some of you have known each other for years. But for some other guys in this call, it's just people you never heard about. So long story short, you can see my face there, the MC of the studio, and based out in the UK and Spain, 50-50, something like that.
All right. Good. And finally, the third way, whether a bundle tool is used for an application or whether the non-ES model files are simply loaded in the browser individually via script tags or other dynamic JavaScript resource loading. If there is no single surrounding scope encompasses all of these pieces, the global scope is the only way for them to cooperate with each other. So, the first is to using directly ES model, right? So the cooperation happens when each model use the import reference to access another model, all right? Uh, this is how now all of these different files stick into one single runtime context for the Java or by the JavaScript engine. Okay, the ES6 is quite straightforward. The other is that bundlers build process typically concatenate as one big files. Okay, they concatenate together to deliver back to the browsers and the JavaScript engine, which then only process one big file, which is the applications located. And in some build step, the entire content of a file, okay, the entire content of a file is wrapped into a scope, an enclosing scope, a function wrapper. Okay, such an enclosing scope, such as function wrapper, aka the universal model, that each piece can access exactly that each piece of code can have access via the local variables in the shared scope, aka you might define as your variables that are assigned to a function expression that contains, well, the logic of that model. And then on the second model variable, you assign now is the function, uh, is the functions, the functionality of that model, and so on and so forth. And then internally, you can reference to those models. That is mind bending. That is mind bending, bro. And finally, and then this wrapping outer scope act like a application Y that contains these top level identifiers. And finally, the third way, whether a build tool is used for an application or whether the non-ES models files are simply loaded in the browser individually via script tags or other dynamic JavaScript resource loading. So whether a build tool is used for an application or whether the non-ES model files are simply loaded in the browser individually via the script tags or other dynamic JavaScript loading, if there is no single surrounding scope encompasses all of these pieces, okay, if there is no single scope encompassing all of these pieces, so the global scope is the only way to cooperate with each other. So instead of you wrapping them inside of a mm-hmm. Okay. So instead of you wrapping them into now a in scope, yeah, instead of you enclosing into an scope, and to cooperate inside of that enclosing scope, aka the function scope, and then define all of these models as variables and referencing inside of that. The another alternative for all of these single files that stick into one single runtime context by JavaScript engine is with the global scope, which is You define all of these different uh, uh, variables that describe is the model functionality, aka you define a variable that has now a function expression. We describe all of the functionality attached to the global scope. A bundle file of this sort often looks like this. Here, since there is no surrounding function scope, this model 1 and model 2 declaration are simple drop into the global scope. This is effectively the same as if the file hasn't been concatenated, but loaded separately. So model 1 this, and then model 2 this, and these files are loaded separately as normal standalone JavaScript files. In the browser environment, each top-level variable declaration will end up as a global variable, since the global scope is the only shared resource between these two separate files. They are independent programs from the perspective of JavaScript engine. In addition to potentially accounting for where an application code resides during runtime and how each piece is able to access the other piece to cooperate, the global scope is also where JavaScript exposes its built-in primitive, native, global functions, namespaces, and friends of JavaScript, internationalization when WebAssembly, and the environment hosting the JavaScript expose its own built-ins. Exactly, the web APIs, the console analytics methods, the DOM, the timers, the web platform APIs. They're just some of the many globals your programs will interact to. So let's take a look now at a little bit of the Eggman script here and the globals. The global. Global environment record. So a global environment record is used to represent the outermost scope that is shared by all ECMAScript elements that are processed in the common realm. A global environment record provides the bindings for built-in globals, clause 19. Okay, for all of the built-in globals. Okay, the global this, the infinity, not a number, undefined function properties of global objects like eval, perform eval, is finite, is nan, parse float, parse int, and URI handling functions. And they call URI, and encode URI, and code URI. Yuri, like a Russian. Yuri. They code URI components. Okay. They code URI and code URI. So this function computes a new version of the UTF-16 encoded, which each instance of certain code points is replaced by one, two, or three, or four escape sequence representing the UTF-8 encoding at code point. Let extra on escape be this. Okay, because it allows you to now escape this and encode this and encode and decode here. And encode and decode here. And the constructor property of the global object, aggregate, array, array buffer, big int, boolean, data view, date, float, functions, internationalization. This is all of the identifiers here map, promise, proxy, range error, reference error, regular expression, set, string, syntax, internationalization, tiki, URI errors, weak map, weak ref, weak set, other property of the global objects, atomics, JSON, math, and reflect. Atomics. What the French says is atomics. The atomic objects. What is an atomic? The atomic object provides functions that operate indivisible on shared memory array cell, as well as functions that let agents wait for the dispatch primitive events. When used with discipline, the atomic function allows multi-agents programs that communicate through shared memory to execute in a well-understood order, even on parallel CPUs. The rules that govern the shared memory communicates are provided by the memory model. So the weighted record. The abstract operation for atomic. Add, compare is log. And the atomic symbol to string tag. Atomic objects. To work with that, with what? To share memory. Objects provide functions that operate indivisible atomically and share memory array cell, as well as functions that let agents wait for dispatch primitives. When used with discipline, the atomic functions allow multi-agents programs that communicate. So when used with discipline, the atomic functions allow multi-agents programs that communicate through shared memory to execute in a well-understood order, even on parallel CPUs. So multiple agents program that can communicate through a shared memory in a well-understood order of even on parallel in a well-understood order. The rules that govern shared memory communicates are provided by the memory model. And this is the memory model. So the memory consistency model specifies the possible ordering seen via accessing type array instance backed by a shared array buffer and via methods on the atomic object. When the program has no data arrays defined below, the ordering of the events appear as sequentially consistent. The memory consists of memory model specify the possible ordering of shared data blocks events arising via accessing type array instance backed by shared array buffer and via method of atomic. Share. Okay, but this is something that goes beyond the scope of this. This is now the memory. We're looking at the scope, but this is all of the things that you can have access to. Makes a lot of sense. Okay. As part of the realm record. Okie dokie. Oops. Okay. Alright. Okay. So where exactly is this global scope? So we answered the question of now how JavaScript makes all of these independent files that act as a single program, okay, to stick into one single execution context by the JavaScript engines. And there are three mechanisms to do this. One of them is that via the way of how they can cooperate. So the question is more simple. How JavaScript actually makes all of these independent files to cooperate, aka to act as a single context execution by JavaScript. So whether it's by using the ES6 model via the import statement that is going to now access to that particular file. This is one. The other is the using a bundle tool that is going to take that program and concatenate into one big file. That's some build step. What it does is to say, hey, this particular file, I'm going to enclose in its own scope, for example, a function scope, and inside of that, define is variables that contain is the models as function expressions that inside of them it can now cooperate that. Okay. Holy, this is mind bending, known as universal model definition. Okay. And the other is now put all of those or so put that file as a global variable, so then now it can cooperate is via the global scope. Via the global scope. Node also expose several elements globally, but they are technically not in the global scope. Require their name and models, URL, and so on. Most developers agree that the global scope shouldn't be dumping ground for every variable in your application. That's a mess of bugs just happens, just waiting to happen. But it's also undeniable that the global scope is an important glue for practically every JavaScript application. So where exactly is this global scope? It might seem obvious that the global it might seem obvious that the global scope is located in the outermost portion of a file, that is, not inside any function or other block, but that's not quite as simply as that. Different JavaScript environments handle the scope of your program, especially the global scope, differently. It is quite common for JavaScript developer to harbor misconceptions without even realizing. Browser window. So with respect to treatment of the global scope, the most pure environment JavaScript can be run in a standalone JavaScript file loaded in a web page. Environment in a browser, I don't mean pure as is nothing automatically added. A lot of may be added, but rather in terms of minimal intrusion of the code of interference with its expected global scope behavior. So consider this file. You get this, right? So when you execute that, you get now, hey, Kyle is doing this, right? So when the code is loaded in a web page environment using an inline script tag, the script tag in the markup or even a dynamically created script DOM elements, in all three cases, the student name and hello identifiers are declared in the global scope. Exactly. So if this JavaScript file is now parsed, is now sent to the browser, the identifiers like student and hello, they will be appends to the global scope. That means if you access the global object, commonly window in the browser, you will find property of the same names there. So for example, window.hello and window.student as well, right? That's the default behavior one will expect from reading of the JavaScript spec. The outer scope is a global scope and student names is legitimately created a global variable. That's what I mean by pure, but unfortunately that won't always be true to all JavaScript environments you encounter, and that's often surprising to JavaScript developers. Global shadowing globals. Recall the discussion of shadowing from chapter 3, where one variable's declaration can override and prevent access to a declaration of the same name from the outer scope. An unusual consequence of the difference between a global variable and a global property, an unusual consequence of the difference between a global variable and a global property of the same name is that within just the global scope itself, a global object property can be shadowed by a global variable. A global object property that can be shadowed by a global variable. Exactly. Global shadowing globals. So if you define now this, and then you, holy hell, something is Kyle, and window does something is 42. Okay. It means that. The let declaration add a something global variable but not as a global object property. Global shadowing globals. The effect then is that something lexically identifier shadow the something global object property. It is almost certain a bad idea to create a divergence between the global object and the global scope. Readers of your code will almost certainly be tripped up here. Exactly, you define here something, and you define here something here, so it's not attaching to the window global object here. So a simple way to avoid this gotcha with global declaration, always use var for global, reserve let and count for block scope. Some gotchas here, especially of where exactly is this global scope. Then you have the DOM globals. I assert that a browser host JavaScript environment has the most pure global scope behavior we'll see. However, it's not entirely pure. One surprising behavior in its global scope you might encounter with browser-based JavaScript apps. A DOM element with an ID attribute automatically creates a global variable that references it. And to consider this markup, it creates now an attribute automatically creates a global variable that references it. And then JavaScript that page could include this. First, in Windows, my to-do list. If the ID value is valid lexical name, if the ID value lexical name like first, the lexical variable is created. If not, the only way to access that global is through the global object window. DOM globals, bro. The auto registration of all of ID bearing DOM elements are global in an old legacy browser behavior that nevertheless must remain because so many old sites rely on it. My advice is never use the global variables, even though they will always be silently created. Holy fuck. Holy French toast. So if this has an ID, so they can be now, if they have an ID, I can have access to this window global. So DOM globals. Holy fuck. And it makes sense because at the end of the day, this window global is not only for JavaScript, but also is for the DOM. Because what window represent is, hell, the window, as you can see, right? And they maintain this is by legacy. And they maintain that it's by legacy here. The auto registration of all of ID bearing DOM as global variable is an old legacy browser behavior that nevertheless must remain because many old sites still rely on it. My advice is never to use the global variables, even though they will always be silently created. Shit, DOM globals. What is window names? Global shadowing. Where exactly is this global scope? Browser window, global shadowing, DOM globals, and what is a window name? Another global scope oddity in browser-based JavaScript. You got this, and the type of is a string. What the fuck? Window.name is predefined global in the browser context. It is a property of a global. What is a window name? What is in window name? Window.name is a predefined global in a browser context. It is a property of the global object, so it seems like a normal global variable, yet it is anything but normal. We use var for declaration, which does not shadow the predefined name. Global property. That means effectively the var declaration is ignored. Since there is already a global scope object property of that name, as we discussed, we have used let name, we will have shadowed window.name with a separate global name. But the truly surprising behavior is that even though we assign the number 42 to name and thus window name, when we then retrieve its value, it is a string. In this case, the weirdness is because name is actually predefined getter and setter on the window object, which insists on its value as string value. Ay, what the hell? Oh, so name. So name is a property. What is in a window name? So window dot name. Oh, okay. So it's doing this coercion here. So with the exception of some rare corner cases like DOM elements ID and window.name, JavaScript running as a standalone file in a browser page has some of the most pure global scope behavior we will encounter. Web workers. Web workers are a web platform extension on top of the browser JavaScript behaviors. Are an extension of on top of the browser JavaScript behavior, which allow a JavaScript file to run in a completely separate thread, operating system-wise. From the thread that's running the main JavaScript program. Since these web workers programs run on a separate threads, they are restricted in their communication with their main application thread. To avoid limit race conditions and other complications. Since these web workers programs run on a separate threads, they are restricted in their communication with the main application threads to avoid limit rate condition on other application. So web worker code does not have access to the DOM to avoid those rare conditions, especially they are restricting in their communication with the main application thread. For example, some web APIs are, however, made available to the worker, such as Navigator. Some web API are, however, made available to the worker, such as Navigator. Since a web worker is treated as a wholly separate program, it does not share the global scope with the main JavaScript program. However, the browser JavaScript engine is still running the code. But since web worker is treated as a wholly separate program, it does not share the global scope with the main JavaScript programs. So we can expect similarly purity of its global scope behavior. Since there is no DOM access, the window alias for the global scope doesn't exist. So web worker is now a are a web platform extension. Okay. Okay. Hmm. So web worker are a web platform extension on top of JavaScript behavior. Okay. So it runs in a completely separate threads, operating system wise, from the thread that is running in the main program. So you have now this JavaScript program running in these threads. You also have the web workers, and to avoid any race conditions, they cannot communicate each other. Okay, and since the web worker is running in a separate thread and doesn't share the global scope, it doesn't have access to the window object or the DOM access. In a web worker, the global object reference is typically made using self. Just as with main JavaScript programs, var and functions declarations create mirror property on the global objects, aka self, where other declarations, let, etc. do not. So again, the global scope behavior we're seeing here is about as pure as it gets for running JavaScript programs. Perhaps it's even more pure since there is no DOM to mock things up. And the developer console realm. Recall to chapter 1 where we get started. The developer tool don't create a completely adhering JavaScript environment. They do process JavaScript code, but they also lean in favor of UX interactions being most friendly to developers, aka developer experience. In some cases, favoring developer experience when typing in short JavaScript snippets over the normal strict step expected for processing a full program produce observable difference in code behavior exactly. So, favoring the DX when typing in short JavaScript snippets over the strict step executed by processing a full JavaScript programs produce observable difference in the code behaviors between programs and tools. For example, certain errors conditions applicable to JavaScript program may be relaxed and not displayed when the code is entering into developer tool. With respect to our discussion here about a scope, such observable difference in behavior may include the behavior of the global scope, hosting, which is what we're going to see in this next chapter, and blocking scope declarations. Let's content see chapter 6 when using the outermost scope. Although it might seem while using the console realm that the statement entering in the outermost scope are being processed in the real global scope, that's not quite accurate. Such tools typically emulate the global scope position to an extent. It is emulating, not a strict adherence. It is emulation, not a strict adherence. This tool environment prioritizes developer convenience, which means that at a time, such as with our current discussion regarding scope, observer behavior may deviate from JavaScript spec. The takeaway is that developer tools prioritize is developer experience when typing short JavaScript snippets over the entire processing of a over the processing of a full JavaScript program, aka its behaviors change and act not as the spec not spec compliant, are not suitable environments to determine or exactly. So the takeaway is that developer tools, while optimizing to be convenient and useful for a variety of developer activities, are not suitable environments to determine or verify explicit or nuanced behavior of an actual JavaScript program context. And the other is the ES6 models. Introduce first class support for the model pattern covered in chapter 8. Holy hell, okay? So in chapter 5 we're gonna see is hosting. Diggy. They don't mention here. Exactly. In chapter 5 we're gonna see hosting. In chapter C we're gonna see is let and counts. And in chapter 7, I don't know what is that, but in any case, but in chapter 8 we're gonna look at the models here. And one of the most obvious impact of using ESM is how it changes the behavior of observably top level scope in a file. Recall this code snippet from early, which we will adjust to ESM format by using the export keyword. Recall this code snippet from early. So if that code is in a file that's loading an ES model, it will still run exactly the same. However, the observable effect from the overall application perspective will be different. Despite being declared at the top level of a model file, in the outermost obvious scope, student and hello are not global variables. Instead, they are model wide, or if you prefer, model global. However, in a model, there is no implicit model wide scope object for these top level declarations to be added to the property, as they are in when declarations appear in the top level of non-models JavaScript file. This is not to say that global variables cannot exist or be accessed in such program. It is just that global variables don't get created by declaring variables in the top level scope of a model. The model's top level scope is descending from the global scope almost as if the entire content of the model were wrapped in a function. Thus, all variables that exist in the global scope, whether they are on the global object or not, are available as lexically identified from inside of the model scope. EXM encourages a minimization of relying on the global scope, where you import whatever models you may need for the current model to operate. As such, you less often see usage of the global scope or its global object. However, as noted earlier, there is still plenty of JavaScript and web globals that you might continue to access from the global scope, whether you realize it or not. There's still plenty of JavaScript and web globals that you will continue to access from the global scope, whether you realize or not. But this is describing that in the ES6 models, global scope does not exist. It doesn't behave like the window objects or like code run in the window. And then you have Node. One aspect of Node that often catch JavaScript developers off guard is that Node treats every single JavaScript file that it loads, including the main you start the Node process with as a model. ESCommon or CommonJS model in C chapter 8. One of the aspects of Node that often catches JavaScript developers off guard is that Node treats every single file that it loads, including the main one you start the node process with as a model. Including is the node process as a model. The practical effect is that the top level of your node program is never actually the global scope. The way it's when it's loading a node model file in the browser. At the time of this writing, Node has recently added support of EXIS model, but additionally, Node has from its beginning supporting a model format referred as CommonJS, which looks like this. So each file in Node, each file in this JavaScript runtimes, instead of be treating as a global scope, they are treating as a model here. So, uh, so those identifiers are now created, but inside of the model, not in the window. Holy hell! Before processing, no effectively wrap your such code in a function, so that the var and function declaration are contained in that wrapping function scope, not treated as global variables. Envision the preceding code as being seen by Node as this. Illustrative, not actual. Okay. It's like exactly. This is like it's wrapping now each one of those files into it in closing scope, similar like a function, but in this case for a model, and then expose that. Node then exactly then injecting all of this again. Node then essentially invokes the added model functions to run your model. You can clearly see why student and hello identifiers are not global, but rather declaring a model scope. As noted earlier, nodes define a number of globals like require, but they are not actually identifiers in the global scope, nor property of the global object. They are injected in the scope of every model, essentially a bit of like the parameter listed in the model functions declaration. So how do you define actual global variables in Node? The only way to do that is to add property to another of nodes automatically. Provide globals, which is ironically called global. Global is a reference to the real object scope object. Somewhat like using window in a browser JavaScript environment. So you can have access to the and now and here we add student as a property on the global object, and then in the console log statement where we're able to access student name as normal global variables. Remember, the identifier global is not defined by JavaScript. It is specifically designed by Node. And reviewing in global this. Reviewing the JavaScript environment we have looked so far at, a program may or may not declare a global variable in the top level scope with var or functions declaration, or let cons and class. Also add a global variable declaration as property of the global scope object if var or function are used for declaration. Refers to the global scope object for adding or retrieving global variable as property with the window in the case of the browser, the self in the case of the web worker, and in the global for the server. I think it is fair to say that global scope access and behavior is more complicated than most developers assume, as the preceding sections have illustrated, but the complexity is never more obvious than in trying to nail down a universally applicable reference to the global scope object. Yet another trick for obtaining a reference to the global scope object looks like this. Oh my god. You say, hey, the global object here, I want you to immediately okay, I want you to immediately run this function and return is this value here. Here we are dynamically is executing this. As a function can be dynamically construct the code stored in a string value with the function construction, similar to the eval. See cheating runtime scope modification in chapter 1. So not only with eval but also with functions you can, oh shit, you can modify the scope of this. Such a function would automatically be run in a non-strict mode for legacy reasons when invoked with normal parentheses. Function invocation as shown. It is this will point to the global object and see the third book in the series of object and classes for more information to determine the this binding. So this, for legacy reason, it will give you now the global object. Eval error. Review. Refuse to evaluate a string as a JavaScript because unsafe eval. Now JavaScript engines say no, I'm not gonna run this, bro. This is pretty weird stuff that you want to do. No. Oh, okay. Okay. Good. So that'll be all for this video. Take care.